Bismillahirrahmanirrahim. Assalamu alaikum everyone. In this video tutorial, we are going to learn about assembly to machine code conversion. There will be one assembly language given, assembly language instruction will be given, and we will be converting it to a machine code or binary code, right? And we will have to follow certain instruction format that is given in this diagram. Basically, this diagram shows very journal format, right? So we need to this diagram actually enlisting the very journal parts of every instruction, right? So we will try to learn about these parts. Okay, you can see that there are number of bytes shown. For example, this is byte 1, then this is byte 2, then byte 3, byte 4, byte 5, then byte 6. We also know that we have already learned in 8086 architecture that the assembly languages size are variable in 8086 microprocessor. They can be of 2 byte, they can be of 4 byte, and they can go up to 6 byte. So the maximum size which can be taken by an assembly language instruction of 8086 microprocessor, it goes up to byte 6. So that is why the general format covers byte 6, but it depends. Sometime we will only use first 2 bytes, or sometime we will use first 4 bytes, or sometime we will use the maximum length, which is 6 bytes, right? But it is a journal format. Okay, let's consider byte 1. This is the byte 1. I hope you can see that this is byte 1, and in this byte there are three different parts. One part is known as opcode. Opcode is something which let us know what to do in what to do or what is to be done by the microprocessor. So this opcode is something which will be given directly in instruction set. For example, for move there will be some other opcode. For add there will be some other opcode. For uh, push there will be some other opcode. So this opcode will be something which will be given in instruction, right? And we do not need to worry. But the important point to note that this opcode is around how many bits? 6 bits. So in first byte 6 bits are basically portion of opcode. Then in 1 byte we know that in total there are 8 bits. So out of 6 bits now only 2 bits are remaining, and these bits are known as d bit and the w bit. The d bit is known as destination bit, or you can say it is related with the uh, register field, which is the portion of, or which is the part of byte 2. So this is the byte 2 information, and out of it there is a 3-bit field which is known as register field. So this field and this D field are related, right? So if one is talking about D field, then he has to consider about register field. And what is it? We know that in every instruction there will be some operands, right? If, for example, I can write a journal instruction, move ax comma bx. So we know that there is basically one ax register involved and one bx register is involved, and ax is what? Destination operand, and bx is what? Source operand, right? This is what we have already learned in so far tutorials, right? So D field actually refers to one of the register. In this given example, both of them are registers, so we have to take one register, right? So this register field is talking about one of the register, right? Either BX or AX, right? It depends. For example, if I'm considering a register BX, then BX is what? Source field, right? So D will become 0. That is a point to understand. If, let me set the font size. Yes. So if register field included in the byte 2 is equal to source, right, is a source register, then D would be what? 0. If register field uh, is destination, for example, if we consider what? AX, then D would be what? 1. So D value actually depends upon the register operand. And if register operand is a source, then D would be what? 0. And similarly, if register operand is destination, then D would be what? Equals to 1. So it is a 1 bit field, D field, but it is related to register operand of one of the register. Okay. Then we come to the, okay, we have talked about what? Let's consider the facts. We have talked about opcode, we have talked about D field, we have talked about register field. Let's consider what is W field. W field is the size bit, right? It lets you know whether your instruction is 16-bit performing 16-bit operation or 8-bit operation. For example, this instruction, right? In this instruction, we can see that a 16-bit register is moved into a 16-bit register. That means this operation is around 16 bits. So W bit is related with the size of operation, right? For example, if we have written the instruction move AL comma BL, can you tell me the size? The size of this instruction would be what? It's an 8-bit operation, right? Because an 8-bit register is moved into another 8-bit register, right? So the W bit is what? W bit is a size bit. Let me write. W bit is a size bit. It's let you know the size of operation, right? And for it will be W is equal to 1 for 16-bit, and W is equal to 0 for 8-bit. This is what something journal and we need to know. Okay, now we are remaining with two fields, and what are those fields are mod and r/m. R/m is basically our second operand. Remember, we have already discussed one of the operand in the register field, so other operand will go either in r/m, and r/m means we are talking about register or memory. So this r/m stands for register or memory. We know that one of the register is already considered in register operand, so other register maybe AX or maybe BX, or maybe other operand is not a register but a memory, right? So the other operand must be encoded in r/m, and that is also related with mode field, because memory uh, can be uh, described by a number of ways. In addressing mode, we have covered there may be uh, this direct displacement, or maybe some base index, or maybe some index, right? So there can be multiple variations of memory. So r/m and its mode is related with each other, and we will see their examples when we are going to cover assembly machine code conversion, right? So what we learn here, that mode and r/m are interrelated, and they are related with the other operand. First operand were discussed in register field, and the other operand is discussed in r/m field, and r/m field may be a memory. And if it is a memory, then we need to know that whether it is base mode or index mode or direct mode, whatever the mode, we will be considering it, and that will be dictated by mode field. Okay, so these are the first two byte. Now we come to the byte 3 and byte 4. Byte 3 and byte 4 are some displacement or some data, right? We have already seen that data can be provided immediately in the instruction. So if it is immediate data, so these two bytes will be dedicated. Lower byte will first, and then higher byte. Okay, and if there is a displacement given, so first lower displacement will be shown and higher displacement will be shown. And in case we are given with displacement and data both, so first we will show the lower displacement, then higher displacement, then lower data and higher data. So these 4 bytes are related with the displacement given in the instruction and the immediate value. I hope we have explained it clearly. Still, if you have any confusion, you can post your queries in comment sections. Let's go to an example where we can actually learn something about it. Okay, these are the charts which are needed to explain various modes, right? Let's discuss them, and then we will take an example of instruction and we convert it, so we will come to know how to use these charts. So first of all, this is the explanation for the memory mode or r slash m, we know that there are two fields which are related, r slash m, which is register slash memory, and it is related with this mode operation, right? So mode is a 2-bit field, so it can be 00, 01, 10, or 11. For 00, that means no displacement. Memory mode, it will be a memory mode but without any displacement, right? And we will see what is that by an example. If memory mode is equal to 01, then it is a memory mode, but we will follow an 8-bit displacement. If it is a 10, then it is a memory mode, but it will follow a 16-bit displacement, right? And if mode is equal to 11, right, then there will be no memory mode, rather it will be simple register mode, right? For example, uh, ax comma bx, cx comma dx. So both of the operand would be what, register, so that will not be a memory mode, rather it will be a register mode. Okay, once this is decided, then we have to take various options. For example, memory mat could be like this: bx plus si, base plus index, right? Bx plus di, base plus index, BP plus SI, base plus index, and so on. So there are various options of R slash M. And we will consider them by example, right? So let's consider an example. Let's check we are converting move BL comma AL. Okay, this is the instruction we want to convert. Remember, the very first thing that we need to know is uh, the opcode, right? What will be the opcode for move? That will be given in the instruction. And for the move, opcode is uh, opcode for move is equals to 1000110. So this is a code which is will be given in your question or in the instruction set. It's something which will be given and we do not need to remember, right? Then we will come to the destination bit. And remember, D is related with another field which is called register field, right? Which is in the byte 2. Register field is 3-bit and D bit is a 1 bit field. So let's consider them. First of all, we need to know which one of the operand is registered. So BL and AL, both of them are what, registered. So we can take any of them, right? Let's say I'm considering register is equal to AL. So uh, AL is what, destination or source? It is a source, so D will become what, 0. Remember, if register will be destination, then we will take D equals to 1. Okay, what is the value of AL? And that you will find over here. Look, in this table, this is a very important step. You need to find AL. Look, this is AL, right? And for AL, you have the value of what, 000. This value is basically for register field as well and for memory, r slash m, and for register is you can use them both, right? So the AL value is what, 000, and it's a 3-bit field. It confirms its value, right? Then we will talk about the W field. The W field is what? W field is the size of operation. Is it 8-bit operation or 16-bit operation? AL comma BL. AL is a 8-bit register, BL is a 8-bit register, so W is a 8-bit operation, so W would be what, 0. And furthermore, you can confirm this W value using comparing this column value. Look, AL written here and W is equal to 0. If AX is written, W is equal to 1. So you can also verify here, right? So now we have written D value, register field, W field, and now what we are remaining with, we are remaining with mode and comma R slash M, right? So we will be considering it. So first of all, mode. Is it a memory mode? BL comma AL. Both of them are registered. It is not a memory mode. So a memory mode, it is a memory mode, it is a memory mode, it is also a memory mode. So this one, register mode, which is 1 1. So both of the operand is 1 1. So sorry, register. So mode will be what? Mode will be 1 1. So mode value would be what? 1 1 1. And other field which is r slash m will also be considered a register. And for BL we need to see a value in the table BL. Look, this is the BL value, and BL value is what? 011, right? R/M column is here, and registers names are mentioned here. So BL and the R/M memory is what? 011. So the value is what? The value is 011. Okay. So now what we need to know, we need to uh, put these values in order, right? So we will write first of all, what was the order? Opcode, then D field, then W field, then mode, then register, and then R/M. It was the order which was defined in the journal format, and we will put the values accordingly. So opcode is what? 1001010. D is what? 0. W is what? 0. Mode is what? 11. Register is what? 000. And R/M is what? 011. Right? Now what we need to do, this is a binary information, right? And we want to put them in hexadecimal. We have already performed what um assembly to machine code conversion, because it was an assembly language, and now we have converted it into binary, but we need to put them in the 4 bits order so that we can convert them also in hexadecimal. So 1000100, okay, and then double one double zero, and double zero double one. So if I convert them, that will become 10008, 10008, double one double zero, that is 12. 12 is what? C. And 0 double zero double one, that means 3, right? So this is in hexadecimal. So uh, what is the result? Move al comma sorry bl comma al is an instruction, and if we convert it into binary or hexadecimal, that would be called 88C3. So this is an example of instruction. I hope you have understand. Let's take another example. Okay, let's consider this example. This is move cx comma dx. So first of all, we will talk about the opcode, right? An opcode move we have already discussed, that is 1001010. Then next thing is what? D bit, and D bit is related with the register field. So register, what we are considering, cx or dx, both of them are register again. So let's consider, last time we took source as a register. This time we take destination as a register. So register is equal to cx, and for cx, if you are considering this table, this cx, the value is what? 0001. So let's say 001, and then destination would be what? 1, because d bit is 1 now, because we are considering r/m, sorry, register operand as a destination operand, right? So the next thing, we will talk about the w. Since cx and dx, both of them are what? Both of them are 16-bit registers, so w will be 1, is a 16-bit operation. Then we will consider mod and r/m. We know that cx and dx, both of them are registers, so there is no memory, it's a register mode. And for register mode, the r mode value what will be? Equals to 1 1. And r/m would be what? We have already considered cx, so r/m would be dx. And for dx, this is the dx, and dx value is what? 010 in the table, 010, right? So these values we have already put now in order. We have already calculated every field. So now let's put them order. So order is what? Opcode, then D, then W bit, then mode, then register, and then R/M. So opcode is was 1001010. D bit is what? 1. W bit is what? 1. Mode is what? 11. Register is what? 00001. And DX is what? 0101, right? So if we arrange them in forwards order, so 100010111, 1100, and what? 1010. So that will lead towards 100 is 8, 10111 is basically 11, which is B, and 1100, that means C, and 1010 means A. So the equivalent assembly instruction of move cx comma dx is 8bca in uh, uh, binary code conversion or machine code conversion, right? Let's take one more example just to understand it further. Now let's consider another example. Move bx dx plus 4567 comma dx. So in this instruction, this is first time we are using a memory mode. So I hope you know that this portion of operand is basically a memory mode, and this is a register. So for register operand, we don't have any uh, information. Or like, okay, let's change this instruction a bit a while. Let's say I'm converting into 8 because we have already done so far move. So let's perform addition operation this time, right? So if we perform the conversion, first of all we need to know what opcode for add. It will be given, and it is basically 000 000. So 6 times zeros. Then we talk about the register field and the comma d field. So register is what? Dx or that memory operand. Of course, it is a dx. And for dx, what is the value? 010 010, right? And will be what? D will be 0 because dx is a source, right? Comma w is a size of operation, and that is what? 16-bit, because there is a 16-bit register is involved, right? So 60 w would be what? 1. Next thing we need to know is r/m or the mode. Mode is what? It is a memory operand, and furthermore, you can see that there is a 16-bit displacement. So it's a memory operand with a 16-bit displacement. Why 16-bit? Because 4567 is a 16-bit number which is used as a displacement in effective address. So 16-bit memory mode, that is our mode will be what? 10. Mode would be what? 10. Okay. Now there is something r/m, and it is something different that we have not done in the last two examples. So r/m would be what? R/m would be uh, register or memory, because this time the second operand is what? Memory. So we will go into this portion of the register, or in this portion of this table we will look for mode is equal to what? Mode is equal to 10. Let me write mode is equal to 10. Okay, uh, let's write downwards so that things will become more easy to understand. Mod is equal to 10, and we know that r/m is a memory, uh, bx plus di plus some displacement, 16-bit displacement. So mode is 10. This is the column, right? And bx plus di is over here. Bx plus di and plus some 16-bit data or displacement. So that is basically what r/m memory. It is a second row, and in second row r/m is what? 0001. This is very, very important. I hope you understand it. Let me elaborate it again. This is mode 10, and here we're looking for this bx plus di, and it is in second row, and it goes to what? 001. That is why these two values are written. Now what we will do, we will write the same instruction: opcode, then d bit comma w, then mode, then r register, then r/m. And of course in this we have also what? Displacement. We don't have any data but some displacement. So displacement will be written like first lower displacement, which is 6-7 hex, comma, then higher displacement 4-5 hex. So this is how bytes will be arranged, right? So now we put the different values. Opcode would be what? 6 zeros. Destination is 0. W is 1. Uh, then mode is 10. Register is what? 010. Then what? r/m is 001. Then 67 hex, comma, 45 hex. Then we will convert the complete into in hexadecimal: 4 zeros, 0001, 1001, and 0001, and 67 hex, comma, 45 hex, right? So 4 times 0 means 0, 0001 means 1, 101 1001 means 9, and 0001 means 1, and 67 means 67, 45 means 45. So this is the equivalent uh, machine code in hexadecimal of this instruction. I hope you have understand this example. We will take one more example just to elaborate it further, right? So we are going to take one more example, and in that we will try to consider some data as well. Okay, let's take one more example. Okay, I have considered one more example, and in that example, what I have changed the memory operand. Now it is a source operand. Let's perform this, and I hope then you will be master of assembly to machine code conversion, right? So first of all, the opcode for it is quite simple. We have already discussed in the last example. It is fixed time zeros. Then we will consider the register field. Register field is AX, and that is what in register AX is was 000, right? And register is what? Destination or source? It is a destination, so D will be what? D will be 1. W would be 1 because it is a 16-bit operation. Then we will talk about mode. Mode is what? Is a BPSI plus some 16-bit. So it's a memory mode. So mode would be what? 16-bit displacement. So mode would be 10, comma, then some uh, BP plus SI plus 16. Okay, let's change some of the instructions. So let's consider it is only 4 5x. So now it is a 16 8-bit displacement, right? So mode would be what? Memory mode, it is a 8-bit displacement. So it 10 will become 01, right? And the next would be what? R/M. R/M is memory mode with 8-bit displacement. We will look in mode 01, and this is BPSI plus D8. So this is the case, and this is this line, third line. So this third line will eventually lead to 010. So the value of R/M is what? 010. Now we will write them in order: opcode, D, then W, then mode, then register, then R/M, then we will put some displacement. We have only given X 8-bit displacement, which is 45 hex, right? So we will change opcode is what? 000, D is what? 1, W is what? 1, mode is what? 01, uh, register is what? 000, R/M what? 010, and then 45 hex. Then we will convert 4 times 0, 0011, then 01, then 01, uh, 00, then 0010, and then 45 hex. So 4 times zeros is 0, 0011, that means 3, 0100 means 4, 0010 means 2, and 45 hex. So this is the equivalent hexadecimal machine code of this instruction. I hope you have understand this assembly to machine code conversion. Still, if you have any example that you do not understand how to convert it, you can post your that examples or questions in comment section, or any confusion you want to ask about this assembly to machine code conversion, you can refer this complete tutorial. There is one more tutorial that I have made about assembly to machine code conversion. I'm giving in the end screen. You can go and watch it. It is also 34 minutes tutorial, and I've given also some 5 different examples in which we have considered some other examples. So I will suggest you, if you want to push and if you want to learn some other data about assembly to machine code conversion, you can watch that tutorial. Okay, that's it from this tutorial. Thank you so much for listening.